All right, let's look at number 3 off of worksheet 31. So we know this is u substitution, and we see limits on there, so we'll have to be careful to change our limits to u limits, as well as changing everything into u stuff. So you guys are getting pretty good at identifying what's the best pick for you. So what do we think the best pick for this one is? A squared minus x squared. And since we're doing this problem with respect to x, that's what dx means. That means any other variable we can treat as a constant. So anything other than x, we're just going to view it as a constant. So when I take the derivative of a squared, it's not 2a. What's the derivative of a squared if a is a constant? You could phrase it 2a dA dx, but dA dx would be 0 because a is a constant. So the derivative of that part is 0. And then minus 2x dx. So this is good, this is close. I'm only off by the negative 2. So I don't know where to put this stuff. I need a negative 1/2 out front. So negative 1/2. Integral. I'm not going to write 0 to a because I know those are going to change because those are x things. I need them to be u things. And then minus 2x dx. That's du. And then u to the 1/2. So I've got the integrand switched over to u stuff. Now I need to switch over the limits. So u of a, okay, that means I'm plugging in a for x, so don't get confused. We've got a's and x's flying around here. A squared minus a squared is 0. So my top limit is 0. And u of 0, so I'm going to plug in 0 for x. A squared minus 0 squared equals a squared. Okay, do you want to integrate that or do you want to do something else? I see somebody doing this. So it's your choice. You could say like, don't mess with it. I'll just do 0 minus a squared. It's fine. And the signs will take care of themselves. Some people are like, that just feels backwards. I want to switch it. That's okay too. So I'll switch it. We'll go 0 to a squared. That means we need to change the sign. But that's not a step you have to do. All right, increase the power by 1. So that would be 3/2. Divide by 3/2. Multiply by 2/3. The 1/2 is still there. And now we want to go 0 to a squared. Probably want to put the 2/3 out front to have less fractions to deal with. So 1/3 a squared to the 3/2 minus 0 to the 3/2. That would be a safe stop. A squared to the 3/2 would be a cubed. So a more simplified answer would be a cubed over 3. But the step before that would be okay. All right, maybe one more from... Oh, 2 questions. Hannah?
Can you do number 9?
Number 9? Same question. Beautiful. Number 9. Oh, this gets back to trig from earlier. Anytime I see a cosine squared, my brain is immediately thinking sine squared plus cosine squared is 1, and maybe there's something related to that involved in this problem. Sine squared plus cosine squared is 1. So, you know what? If I move the cosine squared over, sine is the square root of 1 minus cosine squared. So even before calculus starts on this problem at all, I can replace all of that with sine of x. Now I still have a u du situation, but at least it looks a little bit better.
So for the square root, we just actually
So
equals that.
better?
I guess.
I started with sine squared plus cosine squared is 1. Move things around. Sine is the square root of 1 minus cosine squared. So I can replace 1 minus cosine squared with sine.
And then we just remove that.
This one's kind of weird for who to pick for you, because the derivative of sine is cosine. The derivative of cosine is negative sine. So it doesn't matter on this one. You can pick either one and end up being okay. I still think there's a better choice, because the positive negative thing is easier one way than the other, but you can work it either direction. So which one do you think is easier, to let you be sine or for you to be cosine? Why sine? It stays positive. If u is cosine, if u is sine, then du is cosine, and I don't have to worry about any negatives in there. If I do it the other way around, it'll still work. I'll just have negatives to worry about. So there's u, and the rest of this stuff was du. So the integral of u du, should be an easy one, although I need to fix my limits now. So u of pi over 3, let's see, sine of pi over 3. No, that's the over 4s. Over 3 is the steep angle, so that's root 3 over 2. And u of 0, sine of 0 is 0. So now I've got a colorful problem, but I've got everything switched over to u stuff. So the integral of u, increase the power by 1, divide by the new power. From 0 to root 3 over 2. Not through yet, because that's still calculus stuff left to do. 1/2 root 3 over 2 squared minus 0 squared. Save stop if you want. Want to test your algebra skills? You could simplify it all the way to 3/8. Yes.
Why is it not like sine root 3 over 2 minus sine 0 or like square root?
Okay, really good question. Because I switched everything to use, so I don't have to go back to x stuff.
Okay.
Now, a different way to work that problem, first spare piece of paper here, is when you get here, you can switch it back to x stuff, but if you do that, you got to go back to the original limits. You got to put them back in x. Okay, and so what you ask is a common mistake. People will switch it to u, and then they'll switch it back to x, but they'll leave the u limits. It's like that. You're going back and forth. When you get to this stage, well, at any stage, all your stuff needs to be U stuff or all your stuff needs to be X stuff.
Okay.
It doesn't matter which way you go. Like, so you can switch it back to X if you want, and you're still going to get eventually the same thing.
Okay, so then the root 3 over 2 is like that's a U.
That's a U value. Those are U values.
Okay.
So if you switch it back to X stuff, then you'd have to switch the limits back to X, the original X limits as well. So that's a really good question and a point of confusion when people start switching back and forth. And you can switch back and forth whenever you want, but if you switch, you got to switch everything. No halfway. No half U, half X business. Switch them all or switch them none, but make sure you're all in U and all in X. Number 11. We good with number 11? We need to see something from number 11. I think if you see one of them, you'll be fine. Yes? Okay. Let's do... Oh, I thought they were all the same. 11, 12, 13. They're all similar. You got a preference out of 11, 12, and 13? Let's do 13. 11 has the widest gap, but because it's an even function, you're going to end up just doubling something. Let's do 13, though. The trick on these is to let U be whatever that inside thing is. So let's let U be 3x. Du would then be 3 dx. So I need a 3 and a 1/3. So 1/3 integral. I'm not putting limits on because I'm switching to U stuff, so I don't want to put 1 and 3. That would not be right. F of U du. Right. I do need to switch the limits though. So U of 3 would be 9, and U of 1 would be 3. So I need the limit. So my limits are 3 and 9. So I want the integral from 3 to 9 of f of u du. Well, I don't really have that. I've got 0 to 3 and 0 to 9. But 0 to 9 would be, think about adding the areas, would be 0 to 3 plus 3 to 9. Does that make sense? Right, the area from 0 to 3 plus the area from 3 to 9 would be the area from 0 to 9. So if we want 3 to 9, that's going to be the area from 0 to 9 minus the area from 0 to 3. And we have those answers given to us. So 0 to 9 is 12, 0 to 3 is negative 6, and if you're feeling lazy or efficient, is a better way to say it, you could stop there. If it bugs you to see that simple math just sitting there waiting to be simplified, then you would get 6. All right, let's switch gears and do some review problems.